In this video, I will introduce type 1 error and the related concept of alpha. The null hypothesis states there's no relationship between our variables of interest. In reality, either the null hypothesis is true or it's not true. When we run our study, we can either decide to reject the null hypothesis or fail to reject the null hypothesis. So at the conclusion of our study, we have four possible outcomes. Either we correctly reject the null hypothesis, we correctly fail to reject the null hypothesis, we incorrectly reject the null hypothesis, or we incorrectly fail to reject the null hypothesis. Type 1 error is the case where, in reality, the null hypothesis is true, but in our study, we reject it as false. Type 1 error is represented by the symbol alpha. More technically, alpha represents the probability that we reject the null hypothesis in our study given a true null hypothesis in reality. Alpha goes hand in hand with p-values. At the outset of a research study, scientists identify the amount of type 1 error they are okay with. The standard practice is that scientists are okay with anything less than 5% chance of type 1 error. In other words, scientists typically set a cutoff of 0.05 for alpha. Once our study is run, we conduct a hypothesis test and get a p-value. Say, for example, that we get a p-value of 0.04, which is less than our cutoff of 0.05. In other words, our data show there is a 4% chance that the null hypothesis is true. If we reject the null hypothesis, this means there's a 4% chance that we're wrong. In other words, the probability of us rejecting the null hypothesis, even though in reality the null hypothesis is true, is 4%, or our alpha is 4%. This 4% chance of being wrong is less than the 5% chance we would be okay with at the outset of our study. This is what we call statistical significance. Statistical significance means there's enough evidence to reject the null hypothesis based on our preset alpha value.